If you had to guess which company is most responsible for the AI boom, you'd probably say NVIDIA. And you'd be right.
His company powers everything from OpenAI, Google's programs. You are the stars. This is a celebration of your science, of your work, and your innovations. My second wish for you is to learn to embrace failure.
Except for one small problem. NVIDIA cannot actually make a single AI chip. Not one. Despite designing the most valuable chips on the planet, NVIDIA doesn't own a single factory capable of producing them. Instead, every AI chip NVIDIA designs gets shipped off to one company, in one country, to actually be built. TSMC in Taiwan. But here's where it gets stranger. TSMC, despite being the most advanced chip maker in human history, also can't make these chips alone. They depend entirely on machines built by one single company, in one small country most people couldn't find on a map, ASML, in the Netherlands. So here's the uncomfortable truth at the center of the entire artificial intelligence revolution. The chips powering ChatGPT, self-driving cars, and basically every AI breakthrough you've heard of, all trace back to a single supply chain so narrow, so fragile, that if any one link snapped, the whole thing could grind to a halt. An American design house, a Taiwanese factory, a Dutch machine. That's it. That's the whole stack the future of artificial intelligence rests on. In this video, we're going to trace that chain link by link and ask the question that's keeping policymakers in Washington up at night. What actually happens if one of those links breaks? NVIDIA is what's called a fabless company, meaning they design chips but don't fabricate them. And that's not a weakness by accident, it's the business model. Designing a chip is incredibly valuable. Building one is incredibly expensive. So NVIDIA does the former and pays someone else to do the latter. The problem is, when it comes to genuinely cutting-edge AI chips, there's really only one someone else capable of doing it at the level NVIDIA needs. TSMC currently produces nearly all of NVIDIA's most advanced GPUs, including the Blackwell chips, powering the latest AI data centers. And it's not just about cutting silicon. NVIDIA's chips need something called CodeOS packaging, chip on wafer, on substrate, a process that fuses the processor and high-bandwidth memory into a single unit. Without it, a modern AI chip simply doesn't function the way it needs to. And TSMC is essentially the only company on Earth doing this at scale. NVIDIA briefly experimented with Samsung a few years back to diversify. They came right back to TSMC. Intel has its own factories, and even Intel still goes to TSMC for some of its more advanced chips, because Intel's factories can't match the quality. So step one of the chain is locked in. The most valuable chip designer in the world has no choice but to depend on a single Taiwanese company for literally all of its products. Which raises the obvious question, why is TSMC so impossible to replace?
This could be the world's cleanest factory. It's at the cutting edge of human achievement, where technology meets the future. And it's constantly developing.
If you cannot innovate, you will not survive in this industry.
TSMC isn't just bigger than its competitors. It's operating in a different league entirely. The company produces an estimated 90% or more of the world's most advanced logic chips, anything below the 7-nanometer threshold that modern AI relies on. To put that in perspective, practically every cutting-edge chip in your phone, your laptop, your car, and every AI data center on the planet was either made by TSMC or made using techniques TSMC pioneered. The reason nobody can simply copy this isn't really about money, although it does cost tens of billions of dollars to build a single advanced fab. It's about decades of accumulated, almost invisible expertise. Thousands of process engineers who've spent careers learning to control manufacturing tolerances measured in atoms. You can build the building. You can't just hire the knowledge. Even when the United States convinced TSMC to build factories in Arizona, backed by tens of billions in subsidies, there was a catch nobody likes to advertise. Under what's known as the N2 rule, TSMC's overseas plants are kept at least 2 technology generations behind whatever's running back home in Taiwan. In other words, even America's own TSMC factory isn't allowed to be the most advanced one. So Taiwan isn't just where TSMC happens to be headquartered. It's where the actual frontier of chip-making lives, full stop, which would be a strange enough story on its own. Except TSMC, the most advanced chip maker in the world, can't actually do any of this without a machine that comes from somewhere else entirely.
Fouquet explained why no other company on the planet can do what his can.
Lithography will always be there, right? Because you cannot do anything with lithography. And there will always be the wish to get better lithography.
This is where the story gets genuinely wild. To make chips this small, you need a manufacturing process called extreme ultraviolet lithography, or EUV, essentially using an unbelievably precise form of light to etch patterns smaller than a virus onto silicon wafers. There is exactly one company on Earth that can build EUV machines, ASML, based in a quiet Dutch town called Veldhoven. Not the best company, the only company. Japanese giants Nikon and Canon, who make similar but less advanced lithography tools, never managed to crack EUV at all. These machines are absurd feats of engineering. Each one contains more than 100,000 individual components. Each one costs upward of $200 million, with the newest high-NA versions running over $350 million. And that's before installation, which can take months and an army of engineers. Getting here took ASML roughly 30 years and multiple near bankruptcies. At one point, the project was so financially brutal that TSMC, Intel, and Samsung actually had to invest directly into ASML just to keep EUV research alive. Imagine your suppliers needing to personally fund you so you don't go bankrupt before you can sell them anything. It worked. And now those same 3 companies are stuck buying from the very monopoly they helped create. TSMC alone is estimated to take around 40% of ASML's entire EUV output. There is no plan B. If ASML stopped shipping machines tomorrow, TSMC's most advanced production simply stops too. Not slows down, stops. So now we've got the full picture. NVIDIA depends on TSMC. TSMC depends on ASML, one American design ecosystem, one Taiwanese factory, one Dutch machine. And naturally, the next question everyone asks is the same one Beijing has been asking for almost a decade. Why doesn't China just build one of these themselves?
Because according to a detailed investigation by Reuters, a high-security laboratory in Shenzhen has quietly assembled a prototype EUV lithography system. The machine was reportedly completed in early 2025 and is now undergoing testing.
Since 2019, the Dutch government, under heavy pressure from Washington, has blocked ASML from selling its most advanced EUV machines to China. Not a single one has ever been delivered. You'd think with China's industrial might and government backing, This would just be a matter of time and money. And to be fair, China is spending tens of billions of dollars trying to crack it. But EUV isn't really one invention. It's an entire ecosystem of roughly 5,000 specialized suppliers, each contributing some piece of impossibly precise engineering. Mirrors so smooth that if scaled to the size of Germany, the tallest bump would be under a millimeter. Lasers that vaporize tin droplets 50,000 times a second to generate the right wavelength of light. You can't shortcut your way into building this. You basically have to reinvent it from scratch, component by component, supplier by supplier. China's domestic lithography company, SMEE, has only managed to produce machines roughly equivalent to what ASML was selling back in the mid-2000s, nowhere near EUV. Reports suggest China may have built early EUV prototypes, but most serious industry estimates put genuine commercial-scale Chinese EUV progress somewhere around 2028 to 2030, at the very earliest. And even ASML's own CEO has said China would need many years to catch up. In the meantime, China has found workarounds, heavily reusing older, non-restricted machines to squeeze out near cutting-edge chips through brute force repetition. It's clever. It's also nowhere near as efficient, and it's a gap the US is actively trying to widen, not close. So for now, the wall holds. Which means if you're the United States and you've just realized your entire AI economy depends on a small island 100 miles off the coast of a rival superpower, you're left with one option. Try to bring some of this home, at almost unimaginable cost. The 2022 CHIPS and Science Act put roughly $52.7 billion of taxpayer money on the table to lure advanced chip manufacturing back to American soil. TSMC alone has now committed up to $165 billion to building a sprawling gigafab cluster in Arizona, by far the largest foreign investment in U.S. manufacturing history. It's already producing chips. Apple's getting them. NVIDIA's Blackwell chips are now being made on U.S. soil for the first time ever. But here's the catch nobody likes to say out loud. Building a fab in Arizona doesn't actually mean independence. Remember that N2 rule? America's most advanced domestic factory is still contractually kept behind Taiwan's. TSMC executives have openly said building in the U.S. costs roughly 50% more than building in Taiwan, partly due to labor costs, partly because the deep bench of specialized engineers Taiwan built up over 40 years simply doesn't exist yet in Arizona. TSMC has had to fly Taiwanese engineers in just to get the lines running. In other words, America isn't trying to replace Taiwan. It's trying to build an insurance policy, one that, even in the most optimistic timelines, won't be at full strength until sometime near the end of this decade. Which brings us to the actual nightmare scenario underlying all of this spending. Because the real question isn't whether the U.S. wants to reduce its dependence on Taiwan. It's what happens if that dependence gets tested before the insurance policy is ready. Here's the number that should genuinely unsettle you. Taiwan produces around 90% of the world's most advanced logic chips. Not a lot. Almost all of them. Economists have modeled what happens if that stops. The Rhodium Group puts $1.6 trillion in annual revenue at immediate risk. Bloomberg Economics estimates a first-year global hit of $10 trillion, nearly 10% of world GDP. And this isn't phones getting more expensive. Militaries, hospitals, AI infrastructure, car factories, all of it runs on these chips. Analysts don't call it a supply hiccup. They call it a global tech blackout. This is why Taiwan's chip dominance has a name in foreign policy circles: the Silicon Shield. The idea is that Taiwan is too economically important to touch, because a conflict would devastate China's own tech sector just as badly. Whether that shield actually holds in a real crisis, nobody knows. Deterrence only works until the moment it doesn't. So here's where it lands. The AI revolution doesn't run on American ingenuity, Taiwanese manufacturing, or Dutch engineering alone. It runs on all three simultaneously, with almost no redundancy anywhere in between. NVIDIA designs the chip. TSMC builds it. ASML makes that possible. Pull any one link and the chain is gone. Billions are now being spent trying to change that. Whether the redundancy gets built before this chain gets tested, for real, might be one of the defining questions of this decade. If you want to go deeper on NVIDIA, how they actually built this position and why nobody's caught them yet, that video is on screen right now. And next time, we're going one layer further. Because once the chip is made, the data still has to cross oceans. It does that through cables thinner than a garden hose, sitting on the seabed, owned increasingly, not by governments or telecoms, but by Google, Meta, and Amazon. Why is big tech quietly buying the ocean floor? That's next. See you then.